For as long as human civilization has existed, we have been obsessed with the search for intelligent life. We build radio telescopes to scan the stars. We send probes into the void, hoping for a signal, a pattern, a sign that we are not alone in the universe. We have spent billions of dollars looking up. We should have been looking down. There is a species that has lived alongside us for thousands of years. They thrive in our concrete canyons. They memorize our faces. They understand our traffic laws. They watch us from the power lines, analyzing our routines with a cold, dinosaurian intellect. We always dismissed their vocalizations as noise, the random, chaotic chatter of scavengers. But recently, science did something unprecedented. Researchers took thousands of hours of crow recordings, terabytes of raw audio data, and fed them into a military-grade artificial intelligence. The goal was simple: train the machine to identify basic mating calls. But the machine found something else entirely. It didn't just find patterns, it found syntax, it found grammar, it found a complex descriptive language that has been encoding information about us day after day, year after year. The AI revealed that we are not the observers of this planet. We are the subjects. To understand the magnitude of this discovery, we first have to dismantle a lie that neurology told us for decades. For the longest time, science operated on a bias. We believed the cerebral cortex, the layered outer shell of the brain found in mammals, was the only engine capable of higher thought. Because birds lack a cortex, we assumed they were biological robots, instinctual, reactive, bird-brained. But evolution is not a straight line. It is a branching tree. Recent neuroimaging studies have revealed that corvids, the family containing crows, ravens, and magpies, solved the problem of intelligence with a completely different blueprint. They evolved the pallium. Packed with a neuronal density that rivals chimpanzees, the crow's brain is a supercomputer compressed into the size of a walnut. This structure allows for convergent evolution. They arrived at the same cognitive destination as great apes, but they took a different road. We saw a glimpse of this in 1960 when Jane Goodall shocked the world by proving chimpanzees could make tools. It redefined humanity. But crows? They don't just use tools, they engineer them. In the forests of New Caledonia, these birds seek out the pandanus plant. They don't just grab a stick, they locate a specific type of leaf, they calculate the angle. They use their beaks to shear the leaf, creating a stepped, tapered tool with backward-facing barbs. It is a fishing hook designed to extract larvae from deep inside rotting wood. In captivity, they solve multi-stage puzzles that stump human children. They understand water displacement. They understand physics. But intelligence is useless without the ability to store data. And this is where the crow separates itself from every other animal in the kingdom. They don't just learn, they hold a grudge. In 2006, Professor John Marsloff at the University of Washington designed an experiment that would become the stuff of urban legend. He wanted to test the limits of corvid memory. His team captured 7 local crows to tag them. But during the capture, the researchers wore terrifying rubber masks, exaggerated caveman faces. It was a stressful event for the birds. The hypothesis was straightforward. The 7 captured birds would remember the mask and avoid it. But when Marsloff returned to the campus days later wearing the mask, he wasn't just avoided, he was hunted. The birds recognized the face instantly. They dove at him, they scolded him. But it wasn't just the 7 victims. Other crows, birds that had never been captured, birds that had never seen the mask before, joined the attack. The 7 original subjects had communicated the threat. They had described the face. Marsloff kept the experiment running. 1 year passed, then 2, then 5. The team would periodically walk the campus in the mask. Even after a decade, the reaction was violent. Here's the terrifying part. The average lifespan of a wild crow is often shorter than the duration of that study. By the end of the experiment, many of the original birds were dead.
The flock attacking Marsloff was composed of their children and grandchildren. The knowledge of that specific human face had been passed down through the generations. It had become oral history, a warning etched into the culture of the flock. This proved that crows possess a mechanism to transfer specific visual information to others who have never seen it. But until the introduction of artificial intelligence, we had no idea how they were doing it.
Human ears are flawed instruments. When we hear a crow caw, we hear a monotone sound. Maybe we hear a difference between a happy sound and an angry sound, but we miss the micro details. The nuance of language lives in the milliseconds, the rapid shifts in pitch, the spacing between notes, the harmonic overtones. Researchers deployed deep learning algorithms, the same technology used to detect deepfakes and analyze submarine sonar, to dissect crow vocalizations. They fed the system thousands of varying calls recorded across North America. The AI began to organize the chaos. It arranged the sounds into clusters. First, it identified the basics: food calls, assembly calls, predator alerts. But then, the computer found the sub-dialects. In a specific subset of recordings, the AI flagged a recurring sequence of notes. Let's call it sequence alpha. The metadata showed that sequence alpha only occurred when a specific man, a researcher, often wearing a red hat, entered the area. It wasn't a general alarm. It wasn't the call for human. It was a unique identifier, a name. To confirm this, researchers conducted playback experiments. They played sequence alpha to a group of unrelated crows who had never seen the man. The reaction was instant. The birds adopted a defensive posture, scanning the horizon for a specific height and shape. The sound carried the data of the identity. As the AI dug deeper, it uncovered a vocabulary of intent. The model noticed that alarm calls changed depending on what a human was holding. If a person walked through a park empty-handed, the chatter remained low level. If the same person walked through holding a long stick or a tripod, the network lit up. The AI proved that the crows were distinguishing between passive walker and armed threat. They are not just reacting to stimuli, they are contextualizing it. They are profiling us based on our potential for violence. The implications of this technology are staggering because this information does not stay local. Corvids operate what biologists call a relay network. An observation made by a sentinel crow in a downtown park can be transmitted across the city in under an hour. The AI analysis suggests that these calls function like a news broadcast. A danger dialect can migrate from one territory to another. A crow in Seattle can learn a warning signal that originated miles away, mutating slightly like a regional accent, but retaining the core data. We are living beneath an invisible internet, built on sound waves and social bonds. And, like any civilization, they have their rituals. We have observed crow funerals for years. When a bird dies, the flock gathers. They stand in silence around the body. We used to think this was mourning. The AI suggests it is something colder. It is an inquest. During these gatherings, the vocalizations are low frequency and highly structured. The birds are analyzing the scene. How did he die? Was it a hawk? Was it a car? Was it a human with a trap? Once the cause of death is determined, that data is uploaded to the collective memory. If a crow eats poisoned food in a specific backyard, the entire local population learns to blacklist that yard within days. But they don't just blacklist, they whitelist. The AI detected gift zones, specific vocal patterns associated with humans who feed them or protect them. These humans receive tribute, shiny beads, colored glass, sometimes even lost jewelry. The birds are engaging in a transactional relationship. They are paying for protection. They have judged us.
They have labeled us, and now, thanks to machine learning, we are finally reading their files.
There is one final, unsettling detail from the study that often gets left out of the headlines. Toward the end of the research project, the AI monitoring the flocks picked up a new anomaly. The vocal patterns in the test area began to shift. A new, rapid-fire sequence began to appear in the recordings. It didn't match the food calls, and it didn't match the predator alarms. It was something novel, and it spread faster than any pattern the researchers had seen before. The scientists are still debating what it means, but the timing is suspicious. This new dialect appeared shortly after humans began aggressively recording them. It appeared after we started pointing parabolic microphones at their nests and setting up cameras in their roosts. It suggests a terrifying possibility. For centuries, we assumed the intelligence gap between us and them was a canyon. We assumed we were the only ones capable of analyzing, studying, and decoding. But crows are masters of observation. If they can recognize a face from a decade ago, if they can analyze the intent of a man holding a stick, they can certainly notice when the hairless apes start pointing machines at them. The new pattern might not be a random shift, it might be a warning. We turned our AI on them to figure out what they were saying, and in doing so, we may have alerted them to the fact that we are finally listening. The experiment isn't over. In fact, for the crows, it has probably just begun.